at 1,000 years worth of temperature and compare it to 1,000 years of CO2, you can see how closely they fit together. Now, 1,000 years of CO2 in the mountain glaciers, that's one thing. But in Antarctica, they can go back 650,000 years. This, incidentally, is the first time anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up. We're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, well, let me put it this way. If my classmate from the 6th grade that talked about Africa and South America were here, he would say, did they ever fit together? Most ridiculous thing I've ever heard. But they did, of course. And the relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer because it traps more heat from the sun inside. In the parts of the United States that contain the modern cities of Cleveland, Detroit, New York, in the northern tier, this is the difference between a nice day and having a mile of ice over your head. Keep that in mind when you look at this fact. Carbon dioxide, having never gone above 300 parts per million, here is where CO2 is now. Way above where it's ever been as far back as this record will measure. Now, if you'll bear